In this lesson, we're going to be talking about combinations and permutations and how to solve them. First, a combination is a collection of things in which order does not matter.
A permutation is all possible arrangements of a collection of things where the order does matter. A word you will need to know to solve both of these is called the factorial. It is represented by the symbol an exclamation point. When you see an exclamation point, we say that a factorial is the product of all whole numbers between 1 and n, where n must always be positive. An example is 3 factorial, which equals 3 times 2 times 1 equals 6. An example of a combination is a smoothie. You just kind of throw stuff in there. It doesn't matter the order. You just, whatever you want, boom, ready? Press the button, bam. Man, I'm really having some trouble with my combination. I just cannot seem to get it open. It's just kind of like, whoa.
Stop right there. That's a permutation.
Whoa.
Combination problems. Our formula for combinations is NCR equals n factorial divided by r factorial multiplied by n minus r factorial. Your n is the number of all objects in your set. R is the number of objects you're taking from your set. So our first question, how many different student councils of 7 students from a group of 24 can be chosen? A, 26,342, B, 556,128, C, 24, or D, 346,104. So, to start our problem, our n in our combination problem is 24. So 24 factorial, going with the equation n factorial, all divided by our r, which is 7, multiplied by our n minus r. So 24 minus 7 factorial. So if we're going to simplify this equation down, it'll be 24 factorial divided by 7 times 17 factorial. So we're going to take our calculator and we're going to plug in for 24 factorial, and we get a ridiculously large number, 620,408,401,733,943,936, and 4 zeros, all divided by 7 factorial times 17 factorial, which is 179,266,463,760,384, and 1, 2, 3, 4 zeros. When we simplify this out, we get 346,104, which is answer choice D. Alright, combinations problem number 2. How many combinations can a hungry person make in a smoothie with 7 possible ingredients but only 3 in a blender? So again, our total number is 7 with 3 ingredients multiplied by 7 minus 3. So when we simplify this down, 7 factorial divided by 3 factorial times 4 factorial. Alright, so we're going to multiply out 7 factorial and we get 5,040. Then we're going to multiply 3 factorial times 4 factorial. When we do this, we get 144. After we divide 5,040 by 144, we get 35. 35 is answer choice B. And those are our combination problems.
And now on to permutation problems. The formula for a permutation, npk equals n factorial divided by n minus k factorial. Once again, n is the total number of objects in a set, k is the number of objects taken from a set. Now on to the first question. How many ways can 4 students from a group of 12 be lined up in a lunch line? let's see. So 12 is our n. So 12 factorial over 12 over n minus k, which is 12 minus 4 factorial. So let's simplify that. 8 factorial, which equals 4, 7, 9, 0, 0, 1, 6, 0, 0, divided by 8 factorial, which is a smaller number, 40,320. Add commas, doesn't hurt. Which comes out to B, 11,880. That is our first answer, B. On to the second problem. Out of a group of 20 competing swimmers, how many permutations can be made with the top 3 winning medals from first to third place? Let's see. Once again, 20 is our n, divided by n minus k, 20 minus 3 factorial, which is simplified to 20 factorial over 17 factorial. Now this is a ridiculously big number. You can plug it into your calculator, but just for the sake of it, we will write it out. 2, 4, 3, 2, 9, 0, 2, 0, 0, 8, 1, 7, 6, 6, 4, 0, 0, 0, 0, divided by 17 factorial, which comes out to 3, 5, 5, 6, 8, 7, 4, 2, 8, 0, 9, 6, 0, 0, 0. As you can see, these problems are really, you just plug them into your calculator and it is much easier than dealing with something like this. But let's see what the answer is. Type it into our calculator, which equals 6,840, which is answer C. All right. This is our representation of a technology enhanced problem. As you can see, there are boxes that we have to put the right answer in from our word bank. So let's look at the first box, which goes with this formula. N factorial divided by n minus k factorial. What formula is that? That's the permutation. So drag the permutation answer into this box. Now obviously this is going to be the combination formula, but let's see why. N factorial divided by r factorial times n minus r factorial. We know that's combination, so drag that over. Now the order. In a permutation problem, does order matter or not matter? Order does matter. In a combination problem, does order matter or not matter? It doesn't matter. Now, with permutations, are there more outcomes or less outcomes than in combinations? There are more outcomes. Why? Because the list makes it that way. I mean, because the order makes it important and it turns that way. And in combinations, there are less ways.